let's look at a couple of these little properties of limits. Because one of the things that we'll see is that we can't have a graph of everything. And so we want to know, are there some shortcuts that without the graph we can still do this? Okay, so the first one is the constant rule. That if you have some constant function, it doesn't matter what x is. So in this case I have y equals 2. If x is 2, y is 2. If x is negative 2, y is 2. It doesn't matter what value I try to find the limit at, it will always be whatever that constant is. Okay, so we're going to say that if you ever just see a number right here, so in this case, this would be like me saying, what's the limit of 2? And I could put any number I want here. I'm just going to put that c. Well, that limit is always 2. So whenever you have a constant, I want you to think about, it's just saying no matter what your x value is, that's what your y value is going to be. Okay, so there's a nice little shortcut that we want to know. All right, let's look at the identity rule. So the identity rule is just the line y equals x. Okay, so whatever x is. So what's the limit as x approaches 2? Well, as x approaches 2, y approaches 2. As x approaches 3, y approaches 3. Okay, so again, you want to think of that whenever you see that something that looks like that right there. So I could have said, what's the limit of x as x approaches 5? Well, it'll be 5 because I'm plugging in when x is 5, y is 5. And then you'll start to recognize these, but make sure that you understand where they're coming from. Okay, so let's look at if we're adding, subtracting, multiplying, things like that with limits. So I have two functions here. I've got an f function and a g function. And I could add these functions together. And let's just kind of think, well, what would happen if as x approaches 2? So let's look at as we're going towards 2. Well, on the blue function, it's at 1. And on the red function, it's at 5. Well, we can just add up those limits. So let me show you what that's actually going to look like. So the green one right here, this is f of x plus g of x. So instead of us having to take these functions and graph them, and then say, okay, as x approaches 2, oh look, it's at 6. We can just find the limit at each one and add those together to get that. Okay, so same thing, if we multiplied by something, we could actually do that to the graphs. We could multiply those graphs, just a lot of work. So we want to be able to do the shortcuts. Okay, so let's look at what we got going here on these notes. Okay, so I have that we'll do these together. That's what we're doing. Okay, now I want you to really watch the notation. So they're giving me two graphs here. I've got an f function and I've got a g function. And they want to know what's the limit as x approaches 3 from the right of f of x plus g of x. So I certainly don't want to come up with the graph of those two together. So here's what I'm going to do. And again, important that you look at how I'm writing this. So this is the limit as x approaches 3 from the right of f of x plus the limit as x approaches 3 from the right of g of x. Okay, so I want you to rewrite it just like that. Okay, so as we're coming towards 3 from the right, let's look at the f function. So I'm coming this way. So I'm going up, and it's approaching 6. Okay. Now I'm going to do the g function. Okay, as I'm approaching 3 from the right. Well, as I'm coming from the right, I'm way up here. And it is approaching 8. So if I were to add those functions together and I wanted to know what's the limit as x approaches 3 from the right, it would be 14. Okay, so notice this constant. We had a rule about that. Okay, so watch how I'm going to write this. Oops, I'm going to put the 3 out in front, and I'm going to say the limit as x approaches 5 of f of x minus 2 times the limit as x approaches 5 of g of x. So anytime that we see a constant in there, we're going to pull that right to the front. And again, this is just making the graph skinnier, right? It's just multiplying by a constant. We don't want to do all that. So let's see. The f function, as I'm headed towards 5. And notice that this is a general limit. So as I'm headed towards 5, right here, it's headed towards 2 from both the left and the right. So I've got 3 times 2 minus, okay, let's go to the g function. As we're approaching 5 from both the left and the right, it's approaching 4. So 2 times 4, I have 6 minus 8, negative 2. Okay. Alrighty, let's look at what we got here. So now I'm coming from the left. Actually, let me have you guys go ahead and try C. Let me have you try C and try D. And I'll pause the video. Or right now you're taking the notes. Pause the video, try those, and then turn the video back on and see if you got them right. Okay, so I would do the limit as x approaches negative 5 from the left of f of x minus the limit as x approaches negative 5 from the left of g of x. Okay, negative 5 over here, and we're coming from the left. So we're coming here, and it is approaching 3. Here we're coming to negative 5 from the left, and it is approaching 4. So we're at negative 1. Okay, on this one we're going to write 3 times the limit as x approaches negative 7. So remember that we're checking it both ways. Over the limit as x approaches negative 7. And make sure that you rewrite limit 2 times, both the top and the bottom there. Okay, f of x, as we're approaching negative 7. So negative 7's right there. So we can see the limit exists coming from both directions. It is approaching 5. So 3 times 5. As I go towards negative 7 on g of x, here's negative 7. It exists coming from both ways. It is approaching 3. So if I took that top function and I multiplied it by 3, and then I divided it by the bottom function, and I wanted to know where is the function headed as x is approaching negative 7, it's headed towards 5. Okay, now let's look at what's going to happen in these cases. So I have the limit as x approaches 6 of f of x over the limit as x approaches 6 of g of x. Okay, so as I'm approaching 6, right here, the function is at 0. As I'm approaching 6, right here, the function is approaching 5. 0 divided by anything? 0. Okay, and then let's look at what happens in this case. So we have the limit as x is approaching negative 3 of f of x plus the limit as x approaches negative 3 of g of x. Well, f of x, negative 3 it's approaching 6. -3 on this one, there's an asymptote there. So on this side, from the left-hand side, it's headed towards positive infinity. On the right-hand side, it's headed towards negative infinity. Remember, in order for the limit to exist, it has to approach a number. It can't approach an asymptote. In this case, the limit does not exist. So I can't do a 6 plus a does not exist. The answer would just be that the limit does not exist. Okay. All right, let's see what's happening down here. So sometimes we're not given any pictures at all. We're just given some information. So they gave us some information about these functions. So I'm going to rewrite this as we want the limit as x approaches c of h of x times, and I'm going to put brackets here. And notice that there's parentheses right here. The limit as x approaches c of f of x plus 6. Okay, well, the limit as x approaches c of h of x is 4. So I've got 4 times the limit of f of x as it approaches c is 3 plus 6. So I'm going to get 4 times 9, 36. Okay. All right, over here we have, well, actually, try this one on your own and see what you get. Pause the video and then come back and see if you got it right. Okay, so I'm going to take the limit as x approaches c of f of x times 5 times the limit as x approaches c of g of x. Okay, so that is 3, and then 5, and g of x is -2. So 15 times -2, -30. So not too bad.